Hello everyone, my name is Alexis and I'm a firmware engineer in the embedded apps team at Ledger. Today we'll see how easy it is to develop your own app for Ledger devices based on the boilerplate app. In this short video, we are going to set up the app development environment on a Mac in a few short steps. First, we are going to install and configure Docker and Xquartz. Then we will install VS Code and the Ledger DevTools extension. And finally, I'm going to show you how to start building an embedded app. All right, let's go. Let's go to the Docker website and download the latest version of Docker Desktop. Let's go ahead and copy Docker to the applications folder. And let's open it. We have to wait for the Docker engine to start. Next, we are going to go on the Xquartz website and download the latest version. We install it. Here we need to open Xquartz and configure it. Let's go into the settings. In the security tab, make sure we uncheck authenticate connections and check allow client connections. It is important to restart Xquartz so that the settings are properly applied. This video is meant for Mac users. If you are on Linux or Windows, you will find there are only small differences. On Ubuntu Linux, it is simpler as there is no need to install a Nix server. On Windows, just remember to check the box to disable access control during the first launch of VCX Serve. Now that we have the two prerequisites installed and running, we can go on the VS Code website and download it. Let's open VS Code, go to the Extensions tab, look for Ledger DevTools and install it. The extension is now installed, and we can see there's a Ledger logo that has been added to the sidebar. When we click there, we go to the extension. Since we don't yet have any apps open in the workspace, we see the default welcome screen. Now let's go to the boilerplate app GitHub page, look for the HTTP link, then open a terminal and clone the app. Now we can go back to the extension, click on the Open App Folder button, and look for the boilerplate app that we have just cloned. Go back to the Ledger extension. As you can see, the welcome screen has disappeared and the extension features are displayed. We need to wait for the extension to start a Docker container. The first time this is done, it can take a few minutes because it needs to pull the latest version of the Docker Developer Tools image that contains the latest SDK and all the required tools to build and test applications. Okay. The container is now running. Let's build the app. We can go and select a target device in the drop-down list and click on Build. It's as simple as that. The operation is finished. Finally, we can run the app on the emulator from inside the VS Code extension. You can play with the left and right keys of your keyboard, just as you would with the Nano X buttons. To summarize, we set up our Mac by installing Docker, Xquartz, VS Code and the Ledger DevTools extension. Then we cloned the boilerplate app. And finally, we built the app and ran it on the emulator. So where do you go from here? Well, go ahead and try running the functional tests. You can also load and run the app on a real device, or you can visit the developer portal for more information. My name was Alexis. See you soon. Hello everyone, my name is Alexis and I'm a firmware engineer in the Embedded Apps team. In this video, I will guide you through writing functional tests of apps developed for Ledger devices. First, I'll tell you why functional tests are an important part of the development process. Then, we'll look at the framework you will use for writing tests, which we have developed called Ragger. Next, I'll walk you through the setup process and pinpoint what files you need for these tests. Finally, we'll wrap up with a comprehensive demo using the Ledger VS Code extension and a code walkthrough. This tutorial requires having the prerequisites set up on your computer. For more information on these, please watch the video called Development Environment Quick Start in this series. Right, let's go! Functional tests are essential to ensure that the features of your app work as intended. They confirm that your app can handle all the implemented commands properly, that the screen information is correct, and that the right data is sent back by the app to the client. That is why having the functional tests in the repository of your app is mandatory before we deploy your app on the Ledger Live App Store. Writing tests can be challenging if you depend only on the Speculo simulator or libraries that have low-level APIs to communicate with a physical device. How do we create tests that automate the execution of the end-to-end scenarios we want to validate? In the Embedded Apps team, we have developed a Python tool for this. It is called the Ragger framework. Ragger offers a unified backend interface for writing tests, where the application can run on either a physical device or the Speculo simulator, removing the complexity from the test code. Also, any test duplication is avoided because it is shared across all the supported devices, enabling it to run seamlessly on any of them. A comprehensive, high-level API is available. It is used to define the instructions and string them together to automate navigation in the application flows on the Speculo simulator. Finally, when navigating in the user interface flows, the Ragger API can also compare the screens displayed with reference snapshots. Okay, now let's go ahead and take a look at the test folder of the boilerplate app in VS Code so that we can identify the important files required for setting up Ragger. Here, we will focus on the application client code, the conftest file, and the requirements file. Let's look at the application client code. It includes the classes and functions to communicate with the application. It is important to note that the communication protocol is to be defined according to your specific needs. The specification includes the APDU parameter values, the status words returned by the app, the transaction serialization format, and so on. In boilerplate command sender, the functions to send commands to the app use the backend interface class provided by Ragger, which exchanges data with the app running on an emulator or a real device. Alright, let's move on to the conftest file. This file is required by the PyTest framework, the test runner used by Ragger. There's not much here because the complexity is hidden in Ragger, where a similar file is defined, the base conftest file. This is where so-called fixtures or object instances are created and passed as parameters to all the test cases. These fixtures include the device name on which the test is run, the navigator used to automate navigation, the backend used to communicate with the device or the emulator, and so on. This file is also where we can modify configuration. For instance, the seed used by the emulator. Okay, let's go to the requirements file. Here, we list the dependencies required by Python to run the tests. You will find Ragger, PyTest, and other libraries. Once this file is written, it is possible to use the Python package manager, also known as pip, to automatically install all these dependencies. It's especially useful when tests are run by scripts in the context of continuous integration, or by the Ledger VS Code extension. Alright, let's now take a closer look at a test case in test pubkey command. This test checks that the app handles the getPublicKey command correctly with the confirmation mode enabled. It verifies that the user is prompted to confirm the address generated from the public key on the device screen. Additionally, it confirms that when the user validates it, the app returns the public key derived from the path parameter and the seed used by the emulator. Okay, let's go to the Ledger Extensions tab, select Stacks, and click on Build. We can now execute the tests with display of the emulator enabled. When running tests, the extension uses pip to install the packages from the requirements file in a Docker container. The whole test suite is executed, but let's fast forward to the test case we discussed a moment ago. Let's go over it line by line and see what's happening. This is the entry point of the test. The PyTest runner calls it and passes the fixtures as arguments. As we have seen previously, the fixtures are defined in the conftest file and are instantiated by PyTest. When entering this function, a client instance is created with the backend provided. It is then used to send the getPublicKey command to the app, which in turn displays the first screen of the flow. On stacks, tap events are needed to reach the confirmation screen, so they are defined in this list. The Rager Navigator API is used to execute the instruction list and to compare the screen content with reference snapshots at each step. After the address is confirmed, the response from the app is retrieved and checked. To summarize, in this video, we looked at the importance of functional tests. We introduced the Rager framework and how to set it up. And we saw it in action with the demo detailing the automation of an end-to-end use case. Now you can see how powerful it is. So where do you go from here? Don't hesitate to play around with the many functional tests of the boilerplate app. You can also visit the developer portal for more information. My name was Alexis. See you soon! Hello everyone, my name is Alexis and I'm a firmware engineer in the Embedded Apps team. In this video, we'll see how to perform device operations in the Ledger VS Code extension. We'll look at the quick initial setup, which is a fast way of getting a new device ready with a developer seed. And we'll learn how to load and delete apps on a device. This tutorial requires having the prerequisites set up on your computer. For more information on these, please watch the video called Development Environment Quick Start in this series. Right, let's go! Before we move on, you need to know that device operations are not possible on NanoX. Okay, let's talk about the quick initial device setup. This operation is an easy way of getting a device ready with a seed, also known as secret recovery phrase, and pin code. Keep in mind that the seed phrase used during the quick setup is exclusively for testing. The only safe seed phrase is the one generated by your device as part of the classic setup. The quick initial device setup requires the device to be uninitialized and in recovery mode. If your device is already initialized, you'll need to perform a reset first. There are two ways for that. You can enter 3 wrong pin codes when you turn on your device, or you can use the available option in the settings menu. Let's see how to use the second option on a Nano S Plus. With the device turned on and unlocked, do a long press on both buttons to enter the control center. Then go to Manage Device and Security. From here you can find the reset option. Press both buttons to validate. Now let's see how to enable the recovery mode. With the device turned off, press and hold down the left button. Connect the device to turn it on, and keep holding the left button until the boot menu appears. Select Recovery Mode and press both buttons to enable it. Okay, let's head over to VS Code. First, let's take a look at the extension settings. It allows you to set the pin code, as well as the 12 or 24-word BIP39 seed phrase. Once these are properly set, with the device in recovery mode plugged into the computer, you can select it in the extension and click the Quick Initial Device Setup button. The extension is calling the LedgerBlue Python script to perform the operation. It can take a few minutes, but let's fast forward. That's it! The device is now properly initialized. Great! Now let's talk about loading and deleting apps on a device. For these operations, the device needs to be plugged into the computer and unlocked. The firmware should be updated with the latest version from the Ledger Live app. Finally, for loading, you need to make sure you have built the app for the correct device. Let's go back to VS Code for a demo. Let's open the target selection menu, choose NanoS Plus, and build the app. Now, with the device plugged to the PC and unlocked, just click on the load button. After that, navigate on the device screen to validate the different steps. If the app is already installed on the device, it will be deleted and installed again. Deleting an app is just as easy. Keep the device plugged and unlocked, and click on the delete button. Then, validate the steps on the device screen. To summarize, in this video, we looked at the device operations in the VS Code DevTools extension. We saw how to get a new device up and running, and how to load and delete apps. Feel free to visit the developer portal for more information. My name was Alexis. See you soon!